Tesla bought Gen 3 stuns with a custom-built actuator weighing just 5 pounds, yet capable of delivering 110 pound-feet of torque. Each joint can lift over 45 pounds while consuming only 100 watts of power, setting a new benchmark for energy efficiency in robotics. Tesla only expressed confidence in calling it the most efficient actuator they've ever built. How might this exceptional efficiency reshape the future of humanoid robotics? Before we begin, please help us reach 12,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla bot, Tesla EVs, and the latest news. How is Optimus designed to be both powerful and energy efficient? When Elon Musk claimed,
I think humanoid robots will be the biggest product ever. The demand will be insatiable.
You've said that.
Everyone's going to want one. It's like, basically, who wouldn't want...
how could a humanoid robot be strong enough to lift heavy loads, light enough to move gracefully, and energy efficient enough to operate for hours without recharging? The answer lies in the heart of the machine, its motor system. And unlike most robots on the market, Optimus doesn't rely on off-the-shelf motors. Tesla has redesigned everything from the ground up. Each motor on the Tesla bot is custom-built for its specific location on the body: hip joints, knees, ankles, shoulders, elbows, wrists, even fingers. There's no one-motor-fits-all approach. The leg joints need to handle large amounts of force to lift the robot's entire body when standing or walking. So Tesla developed high-torque motors specifically for those points. Meanwhile, the arms and wrists require agility and fine control for precise gripping, so those motors are tuned for speed and accuracy rather than raw strength. This task-specific design allows Tesla to optimize every pound of weight and every watt of energy the robot uses. Imagine the robot working in a kitchen. When it bends down to pick up a 20-pound bag of potatoes from under the table, the motors in the hips and knees must coordinate to produce smooth, balanced force. These leg motors must be strong enough to lift both the robot and the bag. Immediately after, as it raises the bag onto the countertop, the arm and wrist joints must shift to a lighter, controlled movement to avoid knocking over objects nearby. This ability to shift fluidly between brute strength and delicate precision is rare among today's robots, and it's only possible because of Tesla's smart motor design. Or take another example. Inside a warehouse, Optimus is asked to lift boxes and place them on high shelves. As the arms rise above the shoulders, the robot needs to maintain balance, requiring the legs and hips to compensate. At the same time, the motors in the shoulders and arms must be strong enough to lift the load, but precise enough to place it exactly. This requires fast-responding actuators with dynamic torque control, something Tesla achieves through direct drive motor systems that don't rely on gearboxes or complex mechanical linkages. The result is not only greater efficiency, but significantly faster reaction times when the AI gives movement commands. What makes Tesla's design so exceptional is the power-to-weight ratio of its actuators, which exceeds that of most other humanoid robots. The Gen 3 Tesla bot weighs less than 132 pounds, but can lift objects weighing nearly 45 pounds with both arms. An impressive mechanical feat, especially considering all of its motors are compact and fully integrated without the need for external gears or assistive supports. While industrial robots often rely on large gear systems or bolted-down mounts to achieve similar strength, Optimus achieves it with compact, energy-efficient direct-drive motors. Another major differentiator lies in Tesla's optimization of electromechanical efficiency within each actuator. They've gone beyond just reshaping the outer casing. They've re-engineered the internal coil windings, permanent magnets, current control systems, and embedded the motor controller directly into the actuator module. Unlike conventional motors, which suffer from heat loss and inefficiency during energy conversion, Tesla's system maintains precise, real-time adjustments to frequency, voltage, and current direction in order to generate smooth torque with minimal waste. This reduces heat buildup, conserves energy, and significantly extends motor life. What's even more impressive is that most of Optimus's joints don't need active cooling. There are no fans, coolant pipes, or pump. Cooling is achieved passively through smart component layout and heat-dissipating materials. That's a huge advantage over many existing robots, which often have to compromise on weight or generate significant noise to keep motors from overheating. Tesla's approach makes the robot quieter, more energy efficient, and easier to maintain, especially valuable in home, hospital, or office environments where both noise and power usage matter. Even more crucial is Tesla's design philosophy. Don't overbuild the motors and then throttle them with software. Start by understanding what the robot needs to do, then build motors that are just powerful enough for those real-world tasks. Most home and factory jobs involve slow, repetitive movements that don't demand maximum output. Walking, lifting boxes, wiping surfaces, opening doors, sorting objects. Tesla has accounted for all of this by designing actuators that perform these motions smoothly and consistently, without excess power consumption. This allows the robot to use smaller battery packs, reduce overall weight, and extend usable runtime. It's also the key to hitting a consumer-level price point under $20,000, a figure Elon Musk has openly hinted at, something that could bring about a robotics revolution as significant as the smartphone era. In short, the motor system is the key enabler that turns Optimus from a technology demo into a truly functional product. Strength alone isn't enough. Tesla has proven that with a ground-up design, component-level optimization, energy-saving focus, and scalable production methods, a humanoid robot can be intelligent, powerful, and practical for everyday use. In the world of robotics, where every pound and every minute of battery life counts, what Tesla has achieved with the Gen 3 Optimus motor system isn't just engineering progress. It's the foundation for a product ready to enter the real world and the global market. Once again, please help us reach 12,000 subscribers. This is important for us to stay motivated. Thank you. How does Optimus control its movements so precisely and intelligently? When people see the Tesla bot performing actions like walking, turning, or precisely reaching out to grab a small object on a table, what they're really witnessing isn't just mechanical movement. It's the result of a highly sophisticated control system working silently beneath the surface, a kind of digital nervous system developed by Tesla to unify every actuator and sensor into one cohesive command network. While the mechanical design is impressive, Tesla's real advantage lies in how it optimizes actuation through control technology that few robotics companies today can match. Unlike traditional humanoid robots that separate hardware, motors, sensors, from control software, controllers, Tesla takes a biologically inspired approach, integrating low-level and high-level control into a unified central nervous system. This means that instead of components operating independently and then reporting back, Tesla has built a hierarchical control architecture that processes sensor data and motion commands in real time at the module level, then synchronizes it across the entire robot using a neural network trained by Tesla itself. During a live stream in early 2024, Elon Musk emphasized the brain and the nervous system of Optimus are essentially extensions of what we built for self-driving. It's all real-world AI. Thanks to its foundation in the same AI platform as Tesla's autopilot, the robot doesn't just respond to environmental inputs, it learns how to optimize behavior over time, like a living organism gaining experience. One of the key differences lies in how Tesla applies bio-inspired control algorithms. Rather than relying solely on traditional dynamics equations, Tesla trains deep learning models to handle unpredictable scenarios, such as slips, resistance, or unintentional collisions. This allows Optimus to react flexibly in the real world, where conditions are rarely ideal or consistent. For example, when the robot steps onto a sidewalk that's slightly higher or slicker than expected, foot sensors detect the abnormal slope. The signal is processed locally in the limbs control module, and within milliseconds, torque adjustments in the knee and hip are made to maintain balance. Crucially, this process doesn't need to pass through a central processor and wait for feedback. The distributed control system is intelligent enough to act immediately. This is why Optimus can walk smoothly like a human, rather than in stiff, jerky motions like many robots. Tesla's control system is not just flexible, it's highly energy efficient. Whenever the robot performs a task like reaching for a bottle of water on a kitchen shelf, Tesla's motion planning algorithms calculate the most optimal path, the shortest distance, the fewest joints to move, and the least energy required. As Musk stated during AI Day, it has to be extremely efficient. This is not just about making a robot move, it's about making it useful. And indeed, Optimus doesn't just move, it moves with purpose and maximum conservation. Tesla has also integrated reflexive learning through billions of data points gathered from autonomous driving and factory simulations. Unlike other robotics companies that train every action manually, Tesla has built a smart control network that transfers knowledge across domains. The way a robot balances on a slippery floor may be informed by how an FSD-equipped Tesla handles a wet road. The subtle adjustments it makes to pick up a glass of water might draw from data gathered on the Model Y assembly line. What further sets Tesla apart is that it doesn't treat control systems as separate from hardware. Tesla develops its own control chips, PCBs, firmware, and operating software, so that everything works seamlessly as a unified whole. Its real-time control system processes signals at extremely high speeds, often between 2 and 5 milliseconds, allowing the robot to respond nearly instantaneously. This level of responsiveness is rare in humanoid robotics, where many systems suffer from tens of milliseconds of latency due to fragmented architecture. This precision is essential in tasks requiring rapid reflexes. Picture Optimus working in a crowded restaurant, carrying a tray of drinks. If someone accidentally bumps its shoulder, the robot has less than half a second to rebalance and avoid spilling the tray. Waiting for central AI commands would be too slow. But thanks to Tesla's smart distributed control, torque adjustments are made simultaneously across joints, allowing the robot to react instantly and retain balance. Tesla is also applying reinforcement learning, so the robot can refine its behavior with every attempt. For instance, when Optimus learns to open a refrigerator for the first time, it tries different methods and forces. After several attempts, the control system figures out the most effective strategy without human coding. This real-world adaptability means each repeated action becomes more accurate and more energy efficient than the last, and Musk's ambition doesn't stop there. In a March 2025 livestream, he revealed, "You'll be able to give it a vague command like clean up the living room, and it will figure out the rest on its own." It's a shift from step-by-step command execution to goal-level autonomy, a massive leap for robots living among humans. Ultimately, Tesla's control system isn't just the robot's brain, it's the system that binds all its senses, muscles, and actions into a unified ecosystem. No amount of sophisticated hardware can reach its full potential without intelligent control, and it's here that Tesla truly differentiates itself, not just creating a machine that moves, but one that adapts, reacts, and completes tasks like a true partner in the human world. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.